conference where we are going to speak about digital transformation and autonomous operations. I think today digital has primarily taken center stage in all the facets of business that we are doing. Across value chain, we have seen digital being played in various aspects, be it customer-facing applications, be it improving efficiency of operations, or be it improving safety. I think what we have today is an eminent panel of people from our industry, from oil and gas, who are going to speak about their experiences in autonomous operations. I would like to call upon Mr. Vikas Gupta, GM from HPCL, who has over 3 decades of experience in digital, and he would speak about robotic LPG cylinder loading system and how it improves safety and efficiency at the LPG plant. Thank you.
Good evening to all, and welcome to this event on robotic cylinder loading system for LPG at HPCL. So HPCL, as all of you know, it's a $50 billion plus company having 52 LPG plants and transactions wherein we are serving more than 100 million customers for LPG, and we have something around 50 crores of LPG cylinders which are taking care and which is giving smiles to every kitchen. So I'm sure you must have seen what a cylinder looks like, right? It is fueling your kitchen, you have your methi malai, the corporate lunch again is by HPCL. Now, this LPG cylinder, once we go into the technicalities, is slightly different ball game. Each cylinder, if you recall in your household activity, is something around 30 kgs. And if it's an industrial cylinder, it is around 40 kg of cylinder. Now, this 30 kg of cylinder, if you have to uplift, place it in a truck, just imagine, and you are giving 2 seconds of time, how difficult it is. Similarly, if you are asked to place a 40 kg cylinder in a truck, within 2 seconds time, again it is more challenging. HPCL works on the human center. So how do we help our human workers? That is the core thing which we imbibed into the HPCL culture. We adopt the cutting edge technologies, not only to improve the process efficiencies, not only to streamline the operations, not only to take care of the customers, but for the internal people also who are a part of our workforce. So we feel that HI, which is human intelligence, is always greater than AI, because the alphabet A is 1 and H is more, right? So at HPCL, we believe human intelligence is more, and that is how we gave birth to this robotic LPG cylinder system, right? So, so just a quick brief on this. So this is a cutting edge solution, robotic solution, right? So a lot of industries are trying on the robots, but I think HPCL, at least in Southeast Asia, because that is a place I know, Southeast Asia, we have been able to carve out this as the unique masterpiece. And this system enhances 3 things. One, safety, because safety is in our bloods. So safety is something which we don't compromise. So this enhances the safety, efficiency, and cost effectiveness. This robotic system aligns with the global industry standards. If you talk about the global industry standards in the robotic solution, this system is fully compliant towards that. And since we are on the path of the digital transformation for last maybe several of years, right? So we are helping this into the digital transformation journey. And especially in the hazardous environment, you need to have more focus because you need EXT protection and all those levels. Now, what is the need or rationale behind developing such a product, which is world-class project? So if you have seen the LPG operations, they rely on the manual loading, right? So which is a labor intensive and a high risk job. Because if you go by the numbers, every 2 seconds, 1 cylinder is loaded into a truck. And there are several studies. I have quoted few of them like Maras et al. And Chen 2017. So what we call this as a manual material handling, which is called MMH. Now MMH, if you see, how do you lift the cylinder? So first you lift the cylinder, rotate your hands, put it, throw it on the truck, right, in the 3-layered system. So this causes the musculoskeletal disorders. Now the MSDs, we call it as MSDs, or it can be there for the repetitive strain injuries. This and the workplace accidents. You know, there is always a softer touch towards occupational safety, health. Can we minimize that? Can we have much more health quotient towards the people and decrease the operational cost? Similarly, the cylinders are the property of the OMCs. So national oil companies own those cylinders. If there is a damage in those cylinders, right, it's a cost to you. So the manual handling increases those cylinder damage, safety incidents, and maintenance cost. Now this system tries to eliminate all those risks, right? So as a CEO, we always try to work on mitigating of those risks. So we may like to enhance safety, we may like to have more speed, we may have like to serve more customers in time and precision in operations. So the, coming from all these rationale and need for innovation, we also spoke to many families of the people who are into this business, and they said, yes, it's very painful to lift a 19.5 kg cylinder onto the third. So that's how we feel that HI has to be there more than the AI. So we came to the section where we have developed this, and for this I'll invite my colleague Mr. Sachin to give you a brief intro of this.
Thank you, sir. So I will be covering this about the robotic loading solutions, technical aspect of it. So this solution has been designed by using a servo motors as well as the pneumatic system completely. So as you can see, this is the first of its kind in the industry, oil industry. So this has been designed by using a telescopic boom with the robot. Actually, we have various robots in the industries, but the capacity which they can give production rate. So we need a production rate of around 1600 cylinders approx in a LPG plants. By using a traditional robot, we cannot achieve. So that's why this system has been designed by using a telescopic boom system. So that is the main feature of this system. So why we, we didn't use the existing system and why we have developed the new system. The next, this robo can load around 360 cylinders in 15 minutes. With manual loading, you can load around 360 cylinders in 20 minutes. So that is the main differentiator with the manual loading as well as the telescopic loading. Then it has completely eliminated the manual interventions. So it has zero manual interventions, so by thereby reducing the cost of the manpower in the plants. Then the next, it is customizable for the loading the 19 kg as well as the 14 kg cylinders. So in a plant, so we have the 3-4 types of cylinders which are being loaded in trucks. So this system can be used for the 14.2 kg and 19 kg cylinders. So these are some of the safety features which are developed, which are incorporated in the system to take care of the safety of the humans. So first one is the air fail-safe. So system totally operate by using the pneumatics. So pneumatics basically, since this is a hazardous plant, LPG plants are the hazardous plant where we need to take care of the safety at the location. So all these motors are flame-proof motors. So that's why to enhance the safety, pneumatics is being used. So whenever there is a failure of air pneumatic system, the system will stop further and it will not harm to any manpower which is loading the which is going inside the cylinder. In case of the in case of the failure only, then basically it will not damage the robot system. So that is the main function of the air fail-safe. Then the power failure, there could be a power failure. So for that purpose also it will stop at the position. Then it detects the real-time motion detection. Basically, whenever any intrusion is there inside the trucks, then system can identify that and accordingly it will stop there only and it can take care of the human safety. Then it can also detect the flap. So while loading the cylinder into the truck, so there are the flaps provided the backside of the trucks. So it also detects that and accordingly it will not load the cylinders. Then truck alignment. So some sensors optical sensors are provided inside in these systems, which identifies the position. Correct positioning is a main requirement in this system. So whenever trucks, for the truck alignment checking, these sensors are provided and it takes care of it. So these are the main components of the system. So you can see here. So first one is a telescopic boom. Basically, it takes care of the whenever the boom goes inside the trucks, and also it retracts to optimize the loading of the cylinders. That's second one is a stacker. Stacker basically it aligns the 6 cylinder in a positions to load inside the trucks. So that is the next one. Then the gripper. Gripper basically it's hold the 6 cylinder at a time and stack on the truck inside the trucks. Then the slider is also there, so it takes care of the horizontal movement of the gripper. Then the rotary mechanism is also there, so it provides, there are the 3-dimensional movement of the robots, so it is being controlled by the servo motors. So horizontal, then the vertical, and then y-axis also. The landing wheel also is provided to provide the stability to the complete systems. So laser sensors basically, as I told earlier, it provides the safety. It's detect the intrusion of the person inside the trucks and accordingly stop theirs only. So these are the main components of the systems. Then benefits basically it enhance the worker safety. So it improves the life of the workers, so avoid minimizing the injury to the workers. Then operational efficiency. So basically it can load earlier by using the manual system. We can load around 360 cylinders only. It takes the 20 minutes. This has reduced to 15 minutes. So for 306 cylinder, it takes around 13 minutes. Then the cost optimization. So it for there are the requirement of the 3 manpower in a traditionally manual loading. So it has reduced that manpower requirement, and it is saving the cost to the company. Then it is also minimizing the damage to the cylinders as well. So that is also maintenance cost has reduced. Then environmental and safety compliances also, it is providing the benefit in that regard also. So thanks. Now I will call upon Vikas sir for the next presentation.
Thank you, Sachin. So now you have seen that how we actually deliver these cylinders to your kitchen, whether it's your home kitchen or your industrial kitchen. So though we have 10 crore customers as of now, we would love you to join as a part of HPCL safe cylinders segment, right? So now, is this product only applicable for HPCL, or is it, can it benefit, or can we scale it up? Can we try to collaborate with other industries? Can we help those people? So what's beyond the LPG? So this system, as you have seen, it is applicable for LPG, but let's talk about the medical gas. So if you remember, during the COVID times, oxygen cylinder was a challenge, right? Now, actually, can it help the oxygen cylinders to be loaded, right? So yes, definitely, why not? So can it help the chemical industries? Yes. So a lot of chemicals are there. Now again, chemicals have their own, challenges in terms of safety hazards and all those stuff, right? So chemical industry is another good example. Hazardous goods. Lot of industries work in the hazardous environment. Hazardous goods are there. So these type of equipments or these type of technologies, cutting edge technologies can help them. How about the beverage industry, right? We have a lot of beverage industry in India, which is growing at a CAGR of more than 20%. So this can always help in beverage industry. One of the points which I missed to write is the EV industry, right? So now EV is a part of the Indian mobility segment, right? We say by 2030, 30%. You know how much a battery is weighing? It starts from 300 kgs, goes up to the in Tesla and all that to 1000 kgs. So in a traditional or a old robotic system, the kind of speed you can get is only 400 to 500 units per hour. But in case of this, you can go much beyond that, right? So there are multiple applications by which there can be a global adoption potential is there in across the industries for this kind of innovation. Now, this is kind of a strategic importance to us and industry relevance, because this is the first kind of, we have worked upon this particular segment wherein we are further enhancing it to another industries or another lines of business. And this is a pure replicable model for any automation driven safety solution where you are looking for a worker safety especially, right? So again, human centric, right? So we need to have solutions which are sustainable and human centric, and that is, HPCL has crafted that position as a technology leader wherein we not only drive the solutions only from the operational perspective, but from the human perspective. So this perfectly aligns with the industry 4.0. Now we are taking it forward. You can have warehouse management with this. You can have, integrated with SAP or your kind of ERP systems you have. And it definitely strengthens your regulatory compliance, because regulatory compliance is one of the most challenging risks which boardroom always discuss, right? So, and the future outlook is that since it signifies a holistic approach to safety, efficiency and industry, my request is take it down further to your industries, take it for your all critical applications where you have regulations challenge, where you are focusing on the industrial safety. And by driving innovation and efficiency, we are trying to set a new standard for safety innovation by digital transformation. And I thank you, all the organizers and the event managers, a lovely audience who have been patiently listening to this. Thank you for your patience. Jai Hind.
Thank you. Thank you, Vikas and Sachin, for this insightful presentation on LPG robotic automation. And I'm sure that would have had brought insights about how safety and efficiency can be improved in this entire industry and other industries going forward. I now call upon.
Okay, so my name is Shubham. I'm covering for you.
Okay. I have Shubham here from SLB, who would speak about autonomous sequential startup for multiple electro-submersible pump systems.
So good evening, everyone. I think audience has been very patient, and I think theme of this session is about autonomous operation. So we have seen today a lot of case histories regarding the downstream and midstream industry. I am going to share one of the case studies that we have done in Latin America about solving an operational problem in one of the assets that we use, which is called electrical submersible pump. These are the pumps that are used in the industry for high volume oil discharge from downhole to surface. And I'll go through the problem statement itself. What was the operational pain points, how much it was replicating in terms of dollars that company was experiencing, and then how Schlumberger actually came up with a very innovative solution fit for business purpose. So first let's see about the asset. So this field that I'm talking about, it's a remote field in Ecuador where, because of the weather condition, remote condition of the field, this field has around 200 plus wells producing cumulatively around 70K barrels of oil. And since the name itself applies electrical submersible pump, so it needs electricity. And at those remote sites, only 30% of the wells were powered by local generators, and then 70% of the electricity, 65 to 70% of the electricity comes from the grid. Now, what were the pain points? Pain point is, like the electricity can go at our houses, this grid electricity used to trip. And what we have experienced during our project tenure, around 7 grid trips were observed during a year. And when I say grid trips, around 50 odd wells were connected to one grid. So if if the electricity goes off from one grid, 50 of your ESP wells goes down, 50 number of wells. So that was one of the problem, the power trip. Second thing is, since it was remote field, lot of human travel was required to even restore these pumps back to their stable operational conditions. This meant lot of HSC exposure that was done, and which was not ideal. Lot of manpower means lot of downtime increases if these trips used to happen during the nights because since the nature of the field was remote. And overall, in our experience, we have estimated a revenue loss of around $6 million USD per year. That was a big, actually, motive for us to design a fit for purpose solution for this company. So now, as I was saying, since the existing workflow that this operator has was very manually exhaustive. Why manually exhaustive? That although they have this SCADA system with them, that only helps the operator to detect which wells are shut down. Now, obviously, few things which were not in our control is the time by which the power will get restored from the grid. So that would typically take 1 to 8 hours depending upon how critical the fault is. But after that, what you see in the box is all the processes that we thought can be made autonomous or can be made more rapid. But first I will go through about the existing workflow. So the well selection is because you have to bring one by one well in a sequential way. We cannot load the grid by starting all the wells at once. So the well selection was very important, that the way you start up the well should be in a decreasing order of the production. So you start up the well with the highest production first and so on. Then there were wells which were connected to the SCADA system. You can remotely start up, but few of the wells where the connectivity was very poor, the on-site person has to go and do the startup. And then the stabilization and follow-up. This is a very critical point, and very inaccurate priorities were there when it is a purely human controlled environment, because we all know, we are from the industry, whenever such kind of trips happen, lot of means the people in the control room or in the field, they have their own human intelligence to manage such kind of trips. But sometimes those priorities can be not so accurate. So now what we propose, it's a very innovative way of doing an intelligence right at the edge. We call it edge. So the first box that you see on the left, we are connecting our controllers, ESP controllers, to an edge gateway device. The proprietary name of this technology is Agora Gateway, but I'll stick to the generic words. So it's an edge computing. This is where the intelligence lies. So all the workflow that I'll talk about in my next slide, I just want to re-emphasize that the intelligence is not lying in the SCADA room. It's not a cloud native workflow, it's an edge workflow. And then obviously this device is transmitting the data to the cloud, where the human can monitor the real-time trends and also the progress of the workflow, how it goes. The picture on the right depicts is a very fast forward, very simple installation, a light-weighted box we can say, but in technical terms it's a gateway, edge IoT gateway, and it is directly connected. Only two cables are required to connect between the controller and this IoT gateway. One is to supply 24-volt DC power to the IoT gateway, which is enough to make it operational. And one is the communication cable between the controller and the Agora device, by which we fetch all the operational parameters, pressure, temperatures, frequency, current, voltage, into our workflow for the process to run. Okay, so I will not go individually into the box because it will make the session very boring. What I wanted to say is that this whole workflow which we have highlighted in the green is lying inside the edge gateway. What we have told is, we have tried to replicate a human brain. So if I am an operational engineer, ESP engineer, what steps I would follow to start up this ESP, and mostly we have to think about how the ESP is speed up to its normal back to the frequency where it was operating before. So those kind of sequences involve lot of stabilization behavior detection. So by a human eye, so if we think from a human eye perspective, by a human eye, if we do the trend analysis, we really know at which steps, whether the steps that we are following is translating into a stable behavior, stable response, and then we go along with the ramp up process, or we need to stop and let the well stabilize before ramping up to the final frequency. So the way this algorithm is designed is having three components. One is the pattern detection algorithm that is running into the box. We are using a machine learning program where we are doing a pattern detection of the key parameters such as intake pressure, current, voltage. I won't go into the list. Maybe not all people are familiar with the downhole pumps, but all the key parameters that generally a human see before taking the decision to ramp up are basically the pattern recognition is happening on all those key parameters, and then the step interval of the frequency is already programmed in the edge gateway. So from the base frequency to the final frequency, you reach in a very safe manner, intelligent manner. The third thing is, we were questioned a lot whether the process will stop by itself if something is going wrong. So suppose for a layman example, I'll give you, I'm speeding up my pump from 30 hertz base frequency, and I have to go up to 60 hertz. This is my final frequency. During my automated ramp up at a certain frequency, like 45 hertz, my current started fluctuating. And now, in general, the industry, what we follow is, there is a control room guy who stops the process based on the SOP, standard operating practices. What we try to do is, we have kind of replicated a human eye by a pattern recognition algorithm. So the process will stop itself, and the human, the person who is having the web app interface, he will be notified that, boss, your ramp up process is not completed and is stopped in the middle. So that he knows that, okay, out of my 50 wells which were shut down, these are the 5 wells which now I have to, from a human eye, I have to start up and control. So this was the process. What we achieved is, in a sequential startup, the way we have deployed is, we have targeted a 1 minute delay between each and every pump. So if suppose for example, 50 wells are tripped, in 50 minutes, all the wells will be started up autonomously and ramped up to their final frequency without a human touch. It can be brought down to 5 seconds. This is what we are aiming for. And now, since I am representing SLB, but we have tried this algorithm, we wanted to make this workflow very agnostic, and we are trying to replicate the same algorithm for industry-wide Baker Hughes and Halliburton controllers also. So this is all about startup workflow. I want to stress here, because the theme of the forum is to talk about AI, pattern algorithm, and all those things. This is the graph, what I'm trying to explain, that the key parameters during any startup, any machine startup, we see, like induction motor. Induction motor, we are all familiar. Whenever we start an induction motor, there is always a peak current followed by a stable current. We always, like operational engineers, bypass our high limit of current so that the startup can happen, and then we implement our high algorithm. We try to do the same, that we do not want to tell that a stable region has achieved until we go for a further ramp up. And this is done by a pattern, simple, we took the historical data of various startups and did a pattern machine learning algorithm by doing a pattern match, and we were quite successful here. So one of the demo charts that I'm trying to show here is on intake pressure, but the parameters that were considered for a stabilization algorithm is pressure, temperature, current, voltage. So what happened after this was applied? So this is the previous to that sheet. The blue portion remains the same. We haven't touched, as a part of our solution, we haven't touched on the blue boxes. So shutdown detection still happens. It is detected on our system also, on our SCADA system also. Power grid is out of our control. So until the power grid comes back, we are waiting. But all the green ones, well selection, startup, and stabilization, this is something that we have automated the process. And what it has brought down currently, it has brought down our reaction time from 8 hours to just 2 hours. What we are trying to reach is, we are trying to bring this 2 hours to 15 minutes. As I was trying to explain before, if we reduce the delay time between well by well startup, we believe that we can bring down the response time of this workflow to 15 minutes. Okay, so this is what in our operations, what we have seen till now. This was a project that I'm presenting after 1 year of operationalization. Not only it improved from an operational point of view, safety aspects, less of driving, less of HHC exposure, it has resulted into a saving of almost $4.5 million to our operators, so to which we were providing our services. Again, I want to emphasize all the algorithm intelligence we wanted to bring into an edge IoT gateway, so that we are not reliant on a human eye or a human pressing a remote control button to do such kind of a exhaustive startup where many wells are involved. We are not stopping here. We have a way forward, and we want to extend such use cases to bring more insights from the well side, like generators I was talking about. We want to bring the generators data also into our platform so that we know if the diesel levels are going down, whether we want to optimize the frequency of the pumps to avoid a unwanted shutdown. So those kind of insights will help us to autonomously regulate the frequency of the pumps when such kind of things are happening, that you have a delay in person reaching up to the tank, and your generator is, you're observing the diesel level going down in the generator. Very simple use cases, but it's still very relevant to our upstream industry where a lot of trips are very unwanted. Second thing, as I was saying, that right now startups are happening autonomously. These are high voltage systems. So what happens in oil field in such remote areas is not only like technician and engineers enter the site, lot of commodity people around, they can enter the sites and cables are energized. We do not want unwanted people at the site. So we want to extend the same concept of implementing advanced visual analytics at the well site so that we can stop our autonomous process when we want, when we detect an unwanted person at the site. So I think this is where we want to move forward. And obviously last third point is, we do not want to be labeled as a solution provider only restricted to Schlumberger or the providers of the like of Baker and Halliburton. We want to extend this concept to all kind of VFTs, whether it's a Chinese manufacturers or European manufacturers, so that this solution is fully agnostic to every operator. I think with this, I would like to finish the session. I was not the original speaker. I'm covering up for my guy. So big thank you to Miguel, who was the original presenter. And I will welcome if somebody wants to connect to me, back to me regarding to know more about the solution. Very welcome to connect back. Thank you.
Thank you, Shubham. Thank you for that excellent presentation on how edge IoT gateways can be used to improve efficiency. Thanks a lot. I call upon Suman Senapati. He's a manager in HPCL, and we'll be hearing from him about applications of computer vision and NLP applications in operations. Suman, over to you.
First of all, thanks a lot for having me here and letting me speak. Hi guys, hello everyone. I'm Suman. I'm from HPCL. I'm presently working as manager PRCC. I will have a very different notion of, I'll be taking over from Mr. Vikas, my senior colleague, who was talking about human intelligence. Through my presentation, I'll try to humanize AI to a certain extent, of course. My presentation would have majorly 3 segments. In the first segment, I'll try and explain how CNN, a convolution neural network, works. We'll just have a look at the architecture of CNNs and try to understand how it works from a layman's perspective. I'll try not to use too many jargons. Then we'll have a look at object detection, which is kind of the next level of image classification. I'll speak about how they are different and how we use them. So I'm basically from a refinery background. So my use cases, the ones which we are working on right now, are mainly for the refinery. So I'll be talking about 2 major use cases of computer vision of CNN. One would be for detection of any unwanted fires and smoke in the refinery through CCTV. The other one would be monitoring of flare, the one we have in refineries, and how we can connect them with the existing data, the process data, and whether we can have a prediction system in place which tells you, which helps you control LPG vaporization and unwanted flaring in the refinery. So now this is what basically a foundational model of CNN looks like. So now let's imagine we invert this into a vertical image. So what we have in that case is, imagine a wedding cake, a really large wedding cake with a green candle on top. So each slice of the cake, if you see, it'll be a tapered cake, right? So if you take out slices, each slice will have something called a convolution layer and a pooling layer. How they work is, any image, any sort of an image would have a dimension of a length and a width, and based on the kind of color system, if it's an RGB image, it'll have 3 channels. If it's a CMYK image, it'll have 4 channels. So it's a 3-dimensional vector for me. So when I pass that on into the input layer of a CNN, that gets multiplied with something called a kernel. So kernel in normal neural network terms is basically a matrix of the weights which we derive from any neural network. So I pass it through convolution layers where each of my layer, it gets bulkier. So my, let's say, x cross y cross 3 image becomes x cross y cross 64 in this example. So it gets heavier. So by the time I reach my candle, the green part, it's a very heavy matrix to handle. Now, one important thing to understand is neural networks, whether it's an LLM, like we always use ChatGPT, or in this case a CNN, it only handles numbers. Whatever we pass on, whether we passed a text, we need a tokenizer for text, we need this for images. So we have to pass on only numbers, right? So in this case, it's pretty simple. I need something called a pooling layer, which removes the unwanted data and lets me select only the important features. So this is kind of godsend if you look at it from a architectural purpose. For any conventional neural network, we do the feature selection by ourselves. So a human has to sit down and select the important features based on, of course, certain statistical principles. But in this case, the model does it itself. So the cake handles the feature selection, and the candle does the classification. I'll talk about classification later. So moving on, this is what basically happens when we do convolution. So the green matrix or the green box which you're looking at, it's basically where we store the kernel, the weights of the model. So the weights initially would be very small numbers, depending on what kind of initialization technique you're using. That gets updated like any neural network through backpropagation and gradient descent. So that kind of scans through your entire image, and you get another vector, a 2-dimensional or rather 3-dimensional vector as a process. This is what happens when you pool. So what we are seeing on screen is called max pooling. So after I've multiplied the kernel with the input layer, I get a larger matrix, but I want it to become smaller. It should get tapered so that I can pass it through the candle. So in this case, I am applying something called max pooling. So what I'm doing is, on the top left, for the first 4 boxes, I'm selecting the highest number and passing it on. Similarly, I'm doing it for all the 4 smaller boxes, and I have a 2x2 matrix instead of a 4x4. Talking about kernels, like I was discussing earlier, kernels is basically a matrix of weights. The weights are initialized at first, but again, how you initialize is not important. After you're done with your feature selection, you'll have a set of numbers which would be your final weights that would finally decide what features get passed on to your the major neural network where the classification happens. Now, for the unversed, how classification works is, let's say you pass on a photo of a cat and a dog into this neural network, and you want the neural network to identify at the end of the day, okay, what's the probability that if I pass on another photo which I am not aware of, to tell whether it's a cat or a dog. So the neural network will be able to classify it into these 2 classes. If you have class 1 and 2, it will be able to tell you the probability that the image lies whether in class 1 or class 2. That's fairly simple mathematically when you're not having images. So the cake section again handles the image portion, and you have just numbers. So I'll just go back, so I think it'll be easier to identify. So as you can see, when we are looking at the green segment, we just have a 1-dimensional array, not a multi-dimensional array. So it's 1 cross 1 cross 4096. It's just 1 dimension. It's just numbers, a list of numbers, that's it. So the FC, the fully connected layers, then handles the classification part. So this is fairly simple when you look at from an image classification perspective. Now, moving on, this is the fun part. Image classification sounds fairly simple, right? Now, object detection takes you to the next level. What if in your image you don't have one cat, you have multiple cats? And what if in your image you want to identify where the cats are? You need bounding boxes around it. So that's where the difference lies. I just don't want to look at the image and tell, okay, the cat is present. I really want to tell where the cat is present, and that actually helps. Now forget about the cats, let's talk about the flare. When I'm looking at, let's say I have a CCTV in my refinery and it's looking at a critical equipment which has a tendency to leak often, and there could be a small fire there. Okay, people are always observant, they're taking rounds, but what if in between a round something happens? So you have a CCTV which is looking at it, and it should be able to tell you when the fire occurs. So this image would be able to tell, if you're looking at a very large section of the refinery, where the fire is occurring, and let the person sitting on the DCS know, okay, this is where the fire occurs. So you need the position as well. Looking from a flare's perspective, let's say you want the length of the fire. Object detection would be able to tell you the X and the Y coordinates of the box. So you know the size of the box now. So based on that, let's say you have data from your entire refinery, from all your flare connected valves coming to your historian. From there you can pick up and start building a correlation. Okay, which of the valves are faulty, which is allowing the flaring to happen, and how much time do you have. So like data is the next oil, right? So now you can store these X and Y coordinates in your historian again. So now sky's the limit. Like I was discussing, in image classification you just get a probability. In object detection, it's not just the probability, you have the X and the Y coordinates as well. I'll just breeze through these two. So now how do you know if your model works? So in classification, generally speaking, what we look at is accuracy score, which gives you an overall idea. For mainly for evaluation of classification, what we look at is precision and recall. And if you want one single metric, I would take the harmonic mean of that, that is F1 score. So what, I'll talk about precision because I have MAP next. So in this case, what I have, it's called intersection over union. So how does it work? So the green box is basically there in my image set. So it is what I'm using to train my model. The red box is my prediction. So IOU basically penalizes if the boxes are far away. So if the boxes are far away, you will add both the areas, that gives you the union, and the intersection is only the portion of the areas which are actually intersecting. So if they are overlapping, so your area of intersection and area of union becomes equal, so you have 1. So if they're further away, it's tending to 0. So it kind of penalizes if the boxes move further away, and if you come closer, it rewards you. So that's how it works. The MAP on over and top of this is basically mean average precision. So if you have multi-class classification, for each bounding box, you will have something called a precision and recall. What is precision? When a model predicts, let's say, a positive something, the positive could be a true positive or a false positive from a confusion matrix perspective. So if it's a true positive, divided by the total number of positives the model has predicted is basically precision of the model. So in this case, since I have multiple bounding boxes, let's say I have multiple bounding boxes, so I'll have multiple precision values, right, for each class. So if you take the mean of that, you get MAP. That's the overall idea. Now I'll talk about one of the use cases in short. So what, in this case, we have used an open source database of fire. So this has fire, smoke, and some normal images. So now the model will have 3 separate classes. One are normal, this is 0, and then you have fire and smoke. So this has close to 21,000 images. It's fairly distributed. Why this is needed is if your data set is not distributed, if it's skewed towards one of the classes, your model is biased. It has a tendency to predict, like it will have more false positives and more false negatives, so that's not good. In case of classification, we really try to have a very balanced data set which we are using to train the model. So fortunately this data set was pretty clean, so we went ahead with it. We have used something called faster RCNN. How RCNN works, it basically uses something called RPN to put the bounding boxes on the training data set, and that is used for training of the model. So this basically runs you through all our hyperparameters and all the iterations we have run through. So for iteration 4, which has 50 epochs, 16 batch size, I don't think it's not needed. So we had a fairly good result for that. You can look at MAP 50 and MAP 50 to 95. Okay, what is the number 50 and 50 to 95? Again, going back, we spoke about IOU. So these evaluation matrix basically clubs them together. So when you have 50 value of IOU, the MAP value is 0.77. And when you have an IOU of 50 to 95, the MAP value was 0.45, which is not very good. It's decent, I would say. So this same model we are using now. We are going ahead and going into model deployment and seeing how it works on our existing CCTV cameras. So the deployment route is not very difficult. I'll not again go through the entire route because I have very less time left. So what we do is the model inference which we get from the entire process, we run it through something called ONNX, Open Neural Network Exchange. The parsed model now we use on TensorRT, and finally the CCTV footage which is coming in, we use it through OpenCV, and now we cannot run all the frames which we are getting through the video. So we'll skip a few frames, pass it through the model, and deploy the entire thing on Docker. And this will give you a live result of, let's say if you have 5 footages coming together into one system, it will be able to tell you whenever there's a fire or whenever there's smoke, it will give you an instant detection. Same for the flare detection system. For flare, we have a bounding box around the fire. So we are storing that number presently. Going forward, what we are planning to do is we are planning to see which all parameters from the process is affecting the flare the most. So accordingly, we'll have a system in place to control that, and we can have monetary benefits. I think that's it from my side. Thank you.
Thank you, Suman, for explaining that how to actually make object recognition work. I mean, we have seen this in our life, but I think the intricacies that go behind it, you clearly explained. Thanks a lot. Now we have Mr. Santosh Kumar, who is a senior programming officer from ONGC, who is going to speak about interactive private LLM deployments. Santosh, over to you. Thanks.
Thank you, sir. Good evening, respected seniors and my dear friends. This is Santosh from ONGC, and today I will deliver an interactive private LLM systems, a Dockerized offline deployment of Llama 3 IEW model with Web UI. So you can ask me what it benefit for you. Suppose you want to send a video message or some a particular song to dedicate your girlfriend, so no need to send a simple audio file. By leveraging the power of large language models, you can swap the face of your with Sonu Nigam or any good singer and send to your girlfriend to impress her. Similarly, for enterprise point of view, suppose you will hire a information retrieval system, or means where you can retrieve sensitive information from a repository of a vast amount of data that contains PDF, Word, Excel, or any day-to-day official files. By using this type of solutions, you can get the desired result without using the internet. So there are a lot of cloud-based solutions are available like ChatGPT or your Gemini and Copilot. So many commercial tools are available, but without using the commercial tool, means by using the open source large language models, how we can make this type of solutions. So as I said, leveraging local language models for PDF querying. Earlier it was PDF querying, but nowadays we have used advanced models that can support PDF, Excel, Word, as well as text documents. And we use RAG-based question answer chatbot like system for information retrieval. So as you know, integration of large language model into applications has revolutionized the natural language processing, and the RAG-based approach combines information retrieval with generative models to answer the desired or to answer the specific formats such as you want to export with a tabular format, or you can generate your result using an image format by using the large language models. However, privacy concerns, data sovereignty and cost effectiveness have driven researchers to explore local language models that is viable alternative to cloud-based LLMs. So as we are working in a PSU, we are not, means we never wish to share our information to third-party vendor servers like ChatGPT or any Copilot or any vendors. So for that, we propose this type of solution. And why I have mentioned it is a robust solution, because as per your requirement, you change the LLM model. Suppose earlier we have used Llama 3, but now we are using DeepSeek R2 versions. Okay. So as per your requirement, you can swap the model, simply delink and link the new model, and it will work. So the problem statement is, despite the revolutionary potential of large language model in natural language processing tasks, several challenges hinder their adoption in enterprise and resource-constrained environments. So the points are data privacy and sovereignty, where the enterprise data never shared to any third party or never shared with any competitors, and due to high cost as well as lack of customization, deployment constraints and accessibility challenges, we required a local large language model that is deployed in premises, means in your campus or in your office premises it will be deployed. So the objective of the research is to develop a scalable, secure and efficient large language model system that capable of handling diverse natural language processing tasks using customized data without relying on cloud-based solution or internet access. Means during the installation you require internet, but after deployment no need for internet connectivity. And the study aims to achieve this through an integration of state-of-art mechanisms. We are using three applications, and by integrating three applications we combine the means we form the system, and that system is capable to retrieve your desired information. And the key components are, the first component is Kotaman, and the Kotaman is used as a user friendly interface, and you can customize the interface as per your requirement. And the beauty of this tool is it redirects the API calls. API stands for Application Programming Interface, which is generally used to access the third-party servers, especially in large language models. If you are using ChatGPT, then you have to generate the API key. So by using this tool, the API key is redirected to your local host. Means without internet it will work. And second is Olama. So Olama is a tool is used to deploy your large language models locally. No need to purchase. Several open source models are available in market. You simply download and use it. And in our case, in this study, we download Olama 3.2. Similarly, Web UI, this is also an open source provider that provide intuitive platform to managing and querying the different LLM models, and it facilitates local hosting and interaction with different large language models. Large language model means, let me introduce what is large language model. The large language models are complex neural network models that are trained with huge amount of information. The information may be textual, it may be image or graphical content, or it may be audio or video. As I said, if you deal with audio files, then the model is different. If you deal with video files, the model is different. So, as per your requirement, you select the model. Similarly, the LLM is also trained with the required information while training. And another concept I have not mentioned, RAG. RAG is specially used to improve the performance of the large language models, and it helps to generate your domain specific data set. If you query or you ask a question to ChatGPT or any public LLMs, tell me more about processing or more about interpretation or some well completion report of a particular well. So that model will not able to answer your question, because that domain specific knowledge is not present, not reside, or not available at the time of training the model. But using the RAG based approach, we can provide our own data due to its deployed in our own premises, so there is no data violation or data leakage issue is happened. So by using our own data, we can create the domain specific data set for our LLM. And whenever we interact using the web user interface, so first it will give more priority to the domain expert knowledge, and after that the large language model can mimic like a human being. Okay, so it will interpret, it will understand and generate human languages, and in your own language. Suppose you need the result in Hindi, but actually it is English, you can also accomplish this type of task. So it will translate the language, or you can accomplish various natural language processing problems by using this type of solutions. So this is our workflow of our proposed approach. We simply install and use it, and as I said, we have used two models. One is Olama and second is Mistral. So Olama is sorry, Llama 3 and Mistral. So Mistral, you can ask me why, means what is the requirement for two models. Now if you use Mistral for to generate different Python codes, means if you require some, as my previous speaker told, he's implemented some concept, believe me, within 5 minutes I can generate the code. Okay, and within 10 to 15 minutes you can create an app. Okay, so if you write the prompt accordingly, means you have to first write the prompt, what is your exact requirement, and you write your prompt with within 100 to 120 means or 150 words, then it automatically generates the whole application without your intervention. Okay, and similarly for Android application, for C programming, for different problems, different models are available. So as per our requirement, we use two models. One is Mistral and second is Llama 3. So after that, by using the power of Kotamon, you can disconnect the internet. Means that is our actual objective. Without internet connection, it should be executed in our office premises. So by using the Kotamon, we redirect each and every API calls to our local host, and we accomplish our task. You can also follow the workflow to design your own information retrieval system in your own data with your customized data. So this is the generic methodology, how you planning, what is your requirement, what type of your input data and what are the output data, and is there any specific alignment is required, So as per your detailed analysis of input, output and processing part, you plan accordingly whether you use container or not, whether you have some public data or private data. If public data, better you use the API keys. But if you have some private data, then you go with this type of solution. And I just share some results. By using the model, we can give so many questions, provide so many questions to that model, and the model is replied. This is the simple dashboard of the proposed approach. I just go to the result part. We have uploaded around 1000 Python books and 15 years ONGC annual report and GeoPix annual report to that model. And we ask the question like, what are the achievement of GeoPix? So it generates the result like this. And the beauty of this tool is, it also gives you the citations from where the right side part is the reference from where the information is retrieved. Similarly, you can ask your PDF files, not only a single PDF file, you can ask multiple PDF files, and you can also ask for comparative analysis of different research paper or different PDF files or different chapters using to the system, and the system will reply accordingly. Similarly, suppose you need some summary of your document, it can also generate for you. And for each and every content generation, it will show you the source. Similarly, to improve the trust and confidence, it will also show you the exact page, the table where the information is retrieved. So one limitation of this tool is, suppose the required content is not available, then it will generate the result like this. Unfortunately, I am not able to get the document, but you just follow the following answer. If it is helpful, you just refer. Okay. And if you try to deploy or plan for this type of solution, then you should focus the limitation, that is the hardware constraints. Hardware constraints means suppose I will deploy in my laptop, then it supports only 8 billion parameter, because the laptop contains 16 GB of RAM. And if I will use my workstation, then I can use 731 billion parameters, that is the latest model you can deploy using your workstations. And some other limitations are also you have to consider while planning for the solution. The summary of the research is, here we are using different open source tools. By integrating them and combine the information retrieval system that can interact PDF, Word, Excel, whatever the input file, you can get the desired answer, and without internet connection. And these are my few, we will plan for our future work. We will also generate graphical content in our next models. Thank you so much to allow me to share my research experience among you. Thank you again.
Thank you, Santosh. I think that really helped us understand how do you deploy our own LLMs for data privacy and make our own customized solutions. And now call upon Dr. Shantanu Purohit. He has about 25 years of experience in the oil and gas industry, and he is the team lead for digital business in BPCL. He's going to speak about operational excellence to predictive maintenance. Shantanuji, over to you.
Thank you, Suresh. Good evening, everyone. Thank you for the patience since we are almost in the late evening now. So my topic for my presentation is operational excellence through predictive maintenance, leveraging automation, IT/OT integration, and AI and big data. So this topic is predominantly on the CGD business side, downstream retail side. So if I talk about the brief of CGD, now CGD business, city gas distribution business, it is now expanding a lot, and there is a pull from everywhere towards the clean energy sources, also from the environment perspective. So while fossil fuel part is diminishing, obviously in the Western countries it is diminishing very fast, but in the Indian context it will take some more decades, I believe. So at the same time, the pool from the CGD is in a rise. So while this is a requirement for the environment perspective or for the future, so adoption of cutting edge technologies are also very much important from the beginning, so that it will take up again enhance to the future for the industry. So in BPCL, we have tried for integrating all those cutting edge technologies. So for the CGD concerns and how it could have led to the operational excellence. So that is the topic for my deliberation today. So just to give the overview and the snapshot for BPCL presence in the CGD business. So if I talk about the CGD business in India and BPCL presence, so natural gas account is around 6 to 7% in Indian energy mix right now, and we have a target of 15% by 2030. And if I talk about BPCL growth trajectory, almost 3 times, 3x natural gas sales volume, we are targeting till by 2029. And we have planned to investment of 5.4 billion USD for distribution network expansion in CGD, and of which 1.8 billion we are committed investment over a period of next 5 years. So BPCL has a presence of 53 geographical areas, out of which 27 GAs are BPCL directly are having, and 26 with the BPCL having with their joint ventures. And we have around 2075 odd operational CNG refueling stations right now, and we target to reach more than 500 CNG stations in next 5 years. So in short, BPCL and its JVs covers almost 19% of India's populations, 25% of geographical areas all India, and 32% of the CNG volumes right now. So now coming to the role of advanced technology in operational excellence. What all are the technologies which we can think of or we can adopt for operational excellence? This may be true for CGD, also this may be true for the downstream petrol MSHSD retail outlets as well. So bring back to the CGD parlance. So first one is the IT/OT integrations. So basic of doing something on the AI or something ML using all those cutting edge technologies is required the data first. So data will come from the how far and how strong the IT/OT integration is. So seamless data flow is required, which should be near real time, and to some extent when there is the data or informations are very sensitive and required, it should be on the real time basis. So for this to have, we have to have an automation system at the field level, which will provide and enable us to have a remote monitoring, and along with this we should have a provisioning of interlocks to implement the SOPs. And also we need a enhanced system resilience, which will improve the fault tolerance. So these are the part of the role of IT/OT integration which will be played. Now coming to the uses of AI or ML for this purpose is the uses or use cases. If I talk about first thing which come on the supply chain management side, where demand forecasting is very much important, and analyze the data available and to predict what will be the gas consumption. So today's scenario, all are being done in the manual mode, and it is all depend on the personal perceptions and interpretations. So this will give us the data-based decision-making process, which is help for appropriate demand forecasting. Next will come to the anomaly detection. So we have equipments at field, we have users. Today's scenario, all are the manual users which are monitoring all those equipments. So ML algorithm which will be used to identify the patterns and anomalies for the equipments or different transactions or the behavior as well. And next will come the personalized customer insights. So when you talk about the transactions, it is all about the handling the customers at the field level. So how the behavior of the customers, what is their requirement, what are their need. AI powered analytics will be able to deliver those kind of insights to the service provider, that is the OMCs and the CGD operators, to recommend and to provide that kind of solutions or the availability of those kind of applications to the target audiences. Next is the big topic is the big data analysis. So these are very much required for the purpose of the predictive maintenance. So we are dealing with the multiple set of equipments and different type of different makes of equipments at the one stations. So predictive maintenance is very much required, which will big data analysis will help to analyze the massive data sets, and it will help us anticipate the equipment failures beforehand. So next is the network optimization. While the CGD gas stations are being implemented by all the ventures at all the GAs, so identifying the appropriate locations for putting up the stations, so that will also big data analysis will provide. This will be based on the current MSHD outlet, current requirement. It will be based on the vehicle populations data and so on and so forth. And last one is very much important for the CGD perspective is the regulatory compliance. So there are set of reporting and compliances which are required to be made for the safety and governance perspective, and also to adhere the regulatory standards. So this kind of analysis will give us a trend, will give us the forecasting and the analysis to provide the compliance maybe for the earlier days till and also for the future. So when we are talking about the CGD industry and implementation of the technologies, now what are the use of this kind of IoT, AI or ML technologies in other industries? So if I talk about the manufacturing industry, IoTs are being used in a big way for the real-time monitoring and control of manufacturing processes. Also AI and ML being used to analyze the vast amount of data to identify their pattern for the equipment pattern and also the delivery pattern. If I talk about the healthcare, IoT and AI are being used for in a massive way for monitoring the patient device, and they're collecting the real-time data and analyze them and giving the prescriptive format to the doctors. Also big data provides in the healthcare system, which helps to resource management and personalized treatment for the personal treatment planning for the healthcare seekers. Now if I talk about the transportation, which is again one of the biggest industry here, IoT and AI that connects the vehicles, infrastructures and the logistic systems, which provide the real-time exchange and monitoring of the data. It is helpful for the logistics providers and also to the industry in a big way. And here also big data helps to optimize the routes, predict the demands and also improve the decision making. Now coming back to the CGD business, why it is a required, basically the need. As I told that we have equipment, large number of equipments, we have a different variety of equipment, different requirements. So and presently all those are being humanly managed at the stations level. There is very few and very minuscule remote monitoring and availability of the snapshot at the remote level. So IoT, AI and big data are the technologies which will provide to enhance the equipment reliability first, compliance for the safety, which automates the safety critical monitoring and implementation of SOPs on workflows. Also it will optimize the maintenance of schedules. So IT, OT data integrations, and it will determine the precise maintenance requirement for particular equipment and at particular stations. And at the end of it, it will provide, finally it will lead to the cost efficiency and the resource allocation. Since presently it is being monitored by all those manual and human beings, so resource allocation and cost efficiency is very much important. So the applications in CGD business, so at the bottom level of it, IT/OT integration is very much required. That is the basics of the things. It will provide the input to the AI/ML algorithms, and big data will analyze or based on those data sets. It will finally provide a predictive maintenance advisory or the reports or the inputs to the secondary sets of applications, which will help to us to take an informed decision on the safety and in a compliance perspective, or on the optimize the maintenance schedules, and also to the cost efficiency and the resource allocation part of it. And putting three all together, the optimizing maintenance, cost efficiency and resource allocations, and all the safety and compliance, finally it is leading to a converge towards the operational excellence. Now coming to the implementation process, what we have adopted in BPCLs. First is the data acquisitions. It is the IoT sensors which are connected to the respective equipment to acquire and send data directly to the cloud-based server. Second is the data transfers. All the data transfers keeping in mind the DDoS and other kind of security threats. So encrypted data is being transferred to the cloud server. So third thing is the data classification and processing. All data which are being received at the back end and in the cloud server are being categorized and processed on on cloud to reducing on the activity at the field level. So field people are free now to do all those kind of jugglery and the analysis at the level. And the data modeling, if I talk about all this process data after using this, it consumes to run various models. We have created some models and those are being run for the network expansion part, for the preventive maintenance analysis part and prediction part, and finally it is coming to the monitoring part of it. These process data are being represented through dashboards, through reports, through exceptional monitoring, and sending it to the respective role holders so that they can take a quick decision instead of depending on the field data and the communication errors. So finally this all quick data driven decision making is being taken place. So for this part is concerned based on the data being received from the field and being analyzed using all those cutting edge technologies like AI, ML and the big data analysis. So right side of the screen it is basically showing the schematic diagram how all the equipments and the applications are being connected. So benefits we have achieved. First is reduction in unplanned downtime and operational cost, which proactive maintenance and preventive maintenance getting it from the system, which is helping us to get that reduction of unplanned downtime and operational cost. Second is the extension of the asset lifetime. So as we are able to do the maintenance proactively, so it is helping us to as well as the downtime reduction the downtime, also to maintain the lifespan of the assets. So it is indirectly helping us to extend their lifespan. And finally it is an enhanced decision making, which is a comprehensive view of the network is available at the top of the management, and we are able to take up enhanced decision making, data driven decision making at that level. So coming to the conclusion, with this approach inclusion of this kind of cutting edge technologies in CGD business, what we could achieve in BPCL is the reliability and safety. So predictive maintenance, IoT sensors enablement and real-time monitoring help us for this achieving this reliability and safety standard at the CGD stations. Also these technologies like AI, big data are scalable and sustainable. So these are being used under different sectors. So this CGD will be one of the sectors which can be this technology can be scalable and made sustainable. And these AI ML driven models help us to take the decision, and it is helping us to forecast the demand forecasting, asset management, and predominantly the emergency responses, which is very much critical for the CGD business is concerned. And with these technologies in the CGD business equipped right now with the cutting edge tools and platforms, so infrastructure is future ready. So while CGD will be expanding, as I said, we will be expanding almost double in the next couple of years. The infrastructure is ready to take care of that kind of expansion and holding a sustainable future ahead. Thank you.
Thank you, Shantanu. I think that really helped us understand how IT and OT and analytics can help our industry make it future proof. With this we come to the end of the session. I thank all the panel members from HPCL, Shlumber J, ONGC, BPCL to present their views today. I thank the team present here for their help, and to the audience for your patient hearing. I'm sure we would have all learned how autonomous operations can improve efficiency, safety, and improve our bottom line. Thanks a lot. With this, we close the session. Thanks a lot.